Section 6.6, we're dealing with exponential and log equations. So, how do we solve this kind of exponential equation? This is an exponent equation because the letters are up in the power zone, the exponent zone. So what are we going to do? Well, let me rewrite it right here. 1/2 to the n plus 8 equals 2 to the 6n plus 2. Well, basically what we can do on this problem is make the two bases the same. See how the half and the 2 are kind of similar? How can we do that? Well, did you know that 2 to the negative 1 power, do you know what that is? That's important that you know that. Remember what negative powers do? They flip things upside down. So that's 1 over 2 to the positive 1. In other words, you don't need that anymore. It's a half. Right? Because the positive 1 power down here, 2 to the 1 is just 2. So 2 to the negative power is a half. Remember, negative powers flip things. Okay, so what? Well, that means this half right here, a half is the same as 2 to the negative 1. So this is 2 to the negative 1 to the n plus 8, which is 2 to the 6n plus 2. Okay, why did we do that? Why do we care about that? Well, because now we've made both the bases the same. Both the bases the same. So if that's the case, then the powers must be equal, right? If I'm telling you 2 to some kind of power equals 2 to some other power, well, if these things are equal, the powers couldn't be like 3 and 4. They couldn't be different numbers. 2 to the 3rd would not equal 2 to the 4th, right? The powers would have to be the same. If the bases are the same, then and these things are equal, then the powers have to be the same or they wouldn't be equal. So that means these powers have to be the same. Once we've made the two bases both the same, they're both just a plain 2 now, right? We changed the half to 2. 2 to the negative 1. So now the bases are the same. They're both just 2, and they're equal. So therefore, the powers must be equal, or the things would not be coming out equal. So that means I know the powers must be equal. So negative 1 times n plus 8 must equal 6n plus 2, right? This power must equal that power because 2 to this power equals 2 to that power. So those powers have to be equal. Distribute. Minus n minus 8 is 6n plus 2. So here we have an equation. We're solving for n. How do you solve for the letter when it's on both sides? You get rid of the lower one. So do the opposite of that one. Whatever you do to one side, you have no choice but to do the same thing to the other. These cancel. And we get minus 8 is 7n plus 2, because that was 6n plus 1n. And now we keep going, subtract 2 from both sides, and we get minus 10 is 7n, last step, divide by 7. So that's how they got the answer, minus 10 sevenths for n. So when you have different bases that are almost the same, like 2 and a half, you can make them both 2 by making it 2 to the negative 1 power. That's the same as a half. Remember, negative powers flip things. And once the bases are the same and these things are equal, you know the powers have to be the same. Or 2 to one of them wouldn't equal 2 to the other if the powers weren't the same. All right, let's try the next one. Now, number 2, we're going to do totally differently. In fact, I think I'm going to go back here where I have room to show you number 2. And write it right back here. Number 2, 4 to the x is 38. Now we're trying to solve for x. How can we solve this equation for x? This is an exponential equation, right? It's got an equal sign. That makes it an equation. Two things are equal. And the letter is in the power zone. The letter is the exponent. It's in the power zone, so we call that an exponential equation. So how do you do that? Well, what can we do? It's kind of difficult. Can we subtract 4? Because you know what we got to do. We got to get x alone, don't we? We got to get x alone. We're saying get rid of that 4. Can we subtract 4? No, obviously not. That 4 is not added. We can't subtract it. Can we divide by 4 on both sides? Will that get rid of the 4? No way. That's not 4 times x, right? If it's 4 to the x power. That's totally different, isn't it? So how do you get rid of the how are we going to do this? What do you do when the x is up in the power zone? How are we going to get x alone? Well, here's the trick. You do the opposite. The opposite of an exponent is natural log. Really, any log will do it. So you do natural log, and of course you have to do it on both sides, because whenever you do something new, you got to do it on both sides. So I go natural log, both sides. 4 to the x, 38. So I do natural log on both sides, and then that x will come down to the front. So we get x natural log 4 is natural log 38. Oh, by the way, why did that x come down to the front? Remember, that's one of those 3 log properties. Remember the 3 log properties? Here we go. I'll just say the 3rd log property. It's just the 3rd one. The 3rd log property, that is that the log base b of x to a power, that power can come down to the front. Remember that? So powers can come down to the front. So, and why? Why do powers come down to the front? Because logs are the opposite of exponentials. So they undo each other. And so that power that x that was up in the power zone comes down to the front, like that. And once that x is down in the front, it's out of power, it's really easy to solve this. You just divide both sides by the natural log of 4, because now it's just times, right? Now it's just x times the natural log of 4. No problem there, just divide it, right? Okay, and then hit the buttons on your calculator. Take natural log of 38 divided by natural log of 4. I'm getting 2 point. Now, how many places? They said 4 decimal places, so I'll just give a whole bunch. 2.62, 39637, blah, blah, blah. There's more than we need. Just type that in, and it'll take it. There's a whole bunch of decimal places. So, what do we do then when you have an exponential equation and x is in power? You natural log both sides, and then the power drops down. That's what gets it out of power. So then it's just multiplication, and you can just divide. That's what we're going to be doing a ton of. Let's try number 3. So I'll rewrite number 3 here. It's going to be, whoops, there we go. Very similar to number 2, a little more complex. 200 times 1.2 to the w equals 10,090. So here's the game plan. When x is in power, when x is up in the power zone, step number 1, ln both sides. Step 2, oh, well, actually, you know what? Let me try again. I skipped the real. Step 1. Step 1, get the base to power part alone. I'll show you what I mean by that. Step 2, ln both sides. Step 3, bring the power down to the front. Okay, so here's what we're talking. Here's the equal sign. The W is saying I want to be alone. Get rid of this 200. Get rid of this 1.2 so I can be alone. Well, first off, we have to get this piece alone. So I'm saying get the base to the power alone, so you can natural log it. So first, that means you got to get rid of the 200. So how do we get rid of that 200 so we can get the 1.2 to the w alone? Well, we got to divide by that 200, because that 200 is multiplied on the front there. Boom. So do that. 1.2 to the w, 10,090 divided by 200. I'm getting 50.45. Okay? And then, so that's step 1. We got it alone. Step 2, you know what we're going to do. Let me just rewrite it here for us. We are going to, on step 2 now, L in both sides. And then you bring the power down to the front. So you grab that power and it drops down to the front. And so you've got W times ln of 1.2. That's the third property of logs. Any log. Doesn't have to be natural log, any log, but we'll just use natural log. It's convenient. It's on button right on our calculator. Comes down to the front. Now it's not too bad to get W alone. Now this is just W times, so we just divide off. You just divide both sides by the ln of the 1.2. Boom. W is alone. Hit the buttons on your calculator. I'm doing it right now. Divided by ln 1.2. I'm getting 21.505864778. There's more decimals than you need. They just said 3, at least 3 places, so there's more than we need. So the game plan, when the x is in power, get the base to power alone, ln both sides, bring the power down to the front, and then you can solve. Let's try it again on number 4. So number 4, 3 to the x minus, that's x minus 8, equals 5. So here again, we have x in power. See it up there? X is up here in the power zone. So when x is in the power zone, that's called an exponential equation. Exponent zone. Step 1, get the base to the power alone. The base to the power. It already is, right? The base to the, there's no other number like a 2 out here or something. If so, we'd have to get rid of it. This one already is alone. So step 2, then you're going to ln both sides. So we'll just jump right to that step. Let me rewrite what we've got here. So 3 to the x minus 8 is 5. I'm going to ln this side and ln that side. So I ln both sides, and then what happens? Step 3, power drops down to the front. It's the great quality of logs that they drop their powers down to the front like that. It's the third log property. So x minus 8 ln 3 is ln 5. Now the way I've written that is incorrect. What's wrong is you have to put parentheses around the x minus 8. Why? Because otherwise, if you don't have the parentheses, it means only the 8 is multiplying the ln 3, and the x is just out here separate. Like x separate, subtract 8 multiplied with ln 3. That's what that means if you don't put parentheses. Why is that so terrible? Well, it can't be right because the whole x minus 8 has to go to the front and be a multiplier, not just the 8. So the whole x minus 8 is multiplied, not just the 8. So you got to put parentheses. That way it indicates the whole x minus 8 is multiplying the ln of 3. Now, what do we do from here? Well, this one's a little more tricky. Now that we have parentheses, we have to distribute through the parentheses, right? That's what we always do with anything outside of parentheses, has to distribute through there. So we get x ln 3 minus 8 ln 3 is ln 5. We're still working. X is saying, I want to be alone. We've got him out of power. Down right up here, he was in power in the beginning. We got him down to the base level, but now we got a little more work to do to get him alone. We're going to have to get rid of the this part, the 8. I'm going to add 8 ln 3. Add 8 ln 3 to both sides. And bring down x ln 3 like so. And now, what do we do? What's the last step here to get x alone? Got to divide, right? Because that ln3 is times by the x. See how we're always doing the opposite? This 8 ln3 was subtracted, so we added it. This x is multiplied by the ln3, so we divide it. Like that. Okay, so now type that into your calculator. Now, let me remind you, you have to hit equals when you're done with the numerator before you divide by the ln3 on the bottom. So be careful on that. I'll do it right now on my calculator too. ln5 plus 8 ln3 equals, make sure you hit that equals, and then divide by the ln3 from the denominator. And I'm getting 9.4649735, on and on it goes, 21. It's more than you need. It says that it doesn't say how many decimals, probably 3 or 4 are good enough decimals on that one. There we go. So we're learning how you solve for x and power. You get the base power alone, ln both sides, power drops down, you finish from there. Let's try another one of these. Number 5, it says e to the 5x equals 24. Want to solve for x. So this is same kind of thing. X is in power. So what do we do when x is in power? Get the base to the power alone. It already is alone, right? If there was a number out here like a 2 or whatever, I'd have to divide that off first. Or if there was like a 2 added, I would need to subtract it off first to get that base to the power alone. It already is alone. Step 2, you know what to do. ln both sides. Notice the theme of this section of homework, 6.6, is that powers and logs are opposites of each other. Powers and logs are opposites. So if you have something in power, then you're going to use a log on both sides. And then about halfway through this homework we'll switch and we'll have logs, and then we want to get rid of the log, and the opposite of a log is a power. So that's the theme of this section of homework, 6.6, is that logs and powers are opposites of each other. They're technically called inverse functions. So let's do it. So on this one, let's rewrite this thing here. Okay, so we have e to the 5x is 24, and what are we going to do? ln both sides, because logs are the opposites of powers, because then step 3, the power drops down to the front. So that power is going to drop down to the front. Now we're going to have 5x ln e is ln 24. Now, here's something new. The ln of e is 1. Let me write a note over here. Note. ln of e is 1. Why? Because natural log is the log that has an invisible base of e, and so when you also put e next to it, it just comes out 1. You can check it on your calculator. Just take ln of e if you want, it's 1. So these guys cancel and they're just 1. Super convenient. It just vanishes basically, because it's just 1. 5x times 1 is just 5x, right? And now how do we finish getting x alone here? Just divide by 5. And then hit the buttons on your calculator. ln 24 divided by 5. Oops. I'm getting 0.6356107.661. It goes on and on. So that's good enough accuracy there. Okay, let's try another one like that. Number 6 is very much the same. E to the 2x plus 1 power is 35. So x in power. How do we solve for x in power? Step 1, get the base to the power alone. It already is alone. right? There's not a number in the front like a 3 or anything. If so, we'd have to get rid of it. Step 2, ln both sides. Natural log both sides, as you know, because logs are the opposites of powers. Whoops, it's 2x, isn't it? So we ln both sides, ln. All right, and you know step 3, power drops down to the front. So this power drops down to the front. So 2x plus 1, remember we need parentheses around it. ln e is ln 35. Now remember, ln e is just 1, huh? So this just canceled out and is 1. So this is just 2x plus 1 times 1. And multiplying by 1 doesn't do anything, so this is just 2x plus 1, isn't it? Right? 2x plus 1 times 1 is just 2x plus 1. Okay, so now we just got to finish. Now that we've got x out of power, down on the base level, just get him alone, right? X is saying I want to be alone. So get rid of this 1, subtract 1 from both sides, gonzo. So we have 2x is ln 35 minus 1. Last step to finish getting excellent, divide by 2, boom. So hit the buttons on your calculator. And remember, whenever you do a fraction, you have to do equals at the end of the numerator before you divide by the denominator. So and the 35, it's ln of 35 separate, and then the minus 1 is outside of the ln 35. Hit equals, and then divide by the 2. I'm getting 1.277674031. You know, it goes on and on. That's plenty of decimals right there for x. There it is. Let's try number 7 now. So number 7, 9e to the x minus 2 equals 19. So how do we handle x in power? Step 1, get the base to the power alone. So first step, so that would be actually just this, huh? Have to get that alone. So to get that alone, our first step is to add 2 to both sides. And so we get 9e to the x is 21. And the next step is to divide by the 9, because that 9 is multiplied, right? That 9 is timesed, so the opposite of multiplying is dividing. This 2 is subtracted, the opposite of that is adding. Notice we're always doing the opposite to get things alone, aren't we? So we get down to e to the x is 21 over 9. You could actually reduce that fraction, probably a good idea. Divide by 3, top and bottom, 7/3, right? Okay, so that's all step 1. All of that is getting, see how from the beginning I circled this e to the x and we did all that work to get him alone. That's been step 1 all along. We just had more of it in this problem than the others. So step 1, get the base to the power alone. Step 2, ln both sides. So now on step 2, we got e to the x, we got 7/3. We're going to ln both sides, and that's that step right there. And then finally step 3, power drops down to the front. So this power will drop down to the front, and we have x ln e is ln 7/3. Remember, ln e is just 1. So this cancels, that's just 1, it's just x times 1, so that's just x. X is ln of 7/3. We're done. We just need the buttons on our calculator now. So ln of 7/3. So ln of 7/3, I'm getting 0.847297 m3a-6.6. That's way more than we need. There's our answer. On to number 8. So here we go, number 8. Oops. Put that there we go. So number 8 is 7 to the 4x minus 5 power equals 45. So you know the steps. What do we do when x is in power? Step 1, you get the base to the power piece alone. It already is. This is the base to the power. If there was like a 2 in the front or something like that, we'd have to get rid of it. But the base to the power is already alone. Step 2, ln both sides. So ln, come on in, and ln both sides. So I'll rewrite it here. 7 to the 4x minus 5 is 45. Oops, kind of getting scribbly there. And now we ln both sides, natural log on both sides. Step 3, the power drops down to the front. Down to the front. So this whole power drops down to the front. So and you put parentheses around it. 4x minus 5 times ln 7 is ln 45. So you put parentheses around it like that. Okay, so now, now we need to distribute that ln 7. So it becomes, becomes 4x ln 7 minus 5 ln 7 is natural log of 45. And x is over here saying I want to be alone. So now we've got x out of power. All those first 3 steps were to get x out of power. X is down here on the base level, no longer in the power zone. So we got x out of power. So now we just solve for x. So we do the opposite of everything to get x alone. So first we got to add this 5 ln 7 to both sides. That's the opposite of the fact that it's subtracted. Like that. And then last step to get x alone is we divide by the 4 and the ln 7. Why? Because they're both multiplied by the x, aren't they? That'll get rid of both of them. Whatever you do to one side, you have no choice but to do the same thing to the other to keep them equal, keep the balance. So we divide by that because those were multiplied by the x. Now, when you get this on your calculator, let me write out what you're going to. It's going to be a little tricky in the calculator. You're going to hit ln 45 plus 5 times, that's multiplied by, ln of 7 equals, you're going to hit equals, then divide by. Now, here's the trick. Whenever, what's the best way? I'm trying to tell you the best way. Yeah, let me just do it this way. Whenever you have more than one thing in the numerator or denominator, you should put parentheses around it. See how we have 2 things in the denominator? You don't have to, how about this? You don't have to parenthesize the numerator if you'll just hit equals at the end. Just hit equals when you're done with the numerator. But then for the denominator, you're going to have to put parentheses when you divide by it because you want both those things to be divided on that. So I'll do that also on my calculator. And I'm getting on this one 1.739059.386, blah, 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 blah. It goes on and on like that. There we go. Okay, so one more of these exponential ones. So this is the hardest one. Number 8 is the trickiest exponential one. I'm sorry, number 9. Number 9 is the trickiest exponential one. It's 8 to the 3x minus 2 power equals 10 to the 10x minus 4 power. Okay. So when x is in power, what are the steps? Step number 1. Get the base to the power alone. Get that piece alone. Well, it already is. I mean, this is base to power, and now there's 2 of them. That's why this one's going to be especially hard, because there's 2 base to power. Step 2, ln both sides. So step 1, the base to power, those are already alone. We already have a base to a power and a base to a power. If they had a number in front, like 2 or 3 or something, we'd have to get rid of those, but they don't. So they're already alone. Step 1's already done. Let's go right on to step 2. Okay, and we ln both sides. ln, and then you know the deal, right? Step 3, the power drops down to the front. So this power is going to drop down to the front, and this power is going to drop down to the front, because there's 2 of them now. And so what do we got? 3x minus 2 times ln 8. You got to put parentheses around the power when it drops down to the front, like we've done in the last few problems. That way the whole thing is multiplied, because the whole thing was the power, now the whole thing is the multiplier. Then the ln 8, boom, boom. And so we get 3x ln 8 minus 2 ln 8 equals, and then boom, boom, multiply the ln 10, 10x ln 10 minus 4 ln 10. Okay, so we get to there. Now we're to here, and we're trying to get x alone. So there's the first 3 steps. So here was ln on both sides. Now step 3, the power drops down to the front. Now we're going to go into a whole new thing. Here's the deal. We have 4 terms, and 2 of them have x. So what do you do when x is in 2 places? We've done this earlier in the course. Here it is again. When x is in 2 places, what do? You get the x terms. So step 1, get the x terms on the same side. Get the x terms on the same side. Factor out x, like x with the parenthesis, and then divide. So, first step, get the x terms on the same side. So I'm going to jump this term this way and this term that way. Remember, when things jump to the other side, they switch their sign. So 3x ln 8, and this 10x ln 10 jumps over, becomes minus 10x ln 10 equals, and then this minus 2 ln 8 jumps to the other side, becomes plus 2 ln 8. Right? So when things jump to the other side of the equal sign, they change their sign. We're really just adding them or subtracting them to the other side. Okay, now, so that's step 1, get them on the same side. See how these 2 x terms are now on the same side? Step 2, factor out the x, like x with the big old parenthesis. So x times what will go back to this term? Well, 3 ln 8. Right? Just pull out the x. Minus x times what will go back to this term? 10 ln 10. See how that x could multiply, and we'd be right back to here and here? Equals, and we'll just keep the other side the same. No changes over there. Okay, so we factored out that x. Last step is we're going to divide, as it says right there. Divide. So now to get x alone, our last step to get x alone is just to divide by that whole 3 ln 8 minus 10 ln 10. Divide by 3 ln 8 minus 10 ln 10. Boom, boom. X equals. Now, remember when you do this on your calculator, remember to hit equals at the end of the numerator and then put parentheses around the denominator so that you keep those groups separate. So I'll do that also. Equals, I'm at the end of the numerator. Now divide by parenthesis the whole denominator. 3 ln 8 minus 10 ln 10. On number 8, so I'm getting 0.3009 053, 983, and goes on and on. So there we go. Okay. On to number 10. So number 10, here we go. Yeah, number 10, because that one was number 9. So number 10. So log base 2 of 5x plus 3 equals 1. So how do we solve a log? Well, remember what we have learned. Logs and powers are opposites. That's really the theme of this section of the course. Logs and powers are opposites of each other. Right? So if you have a power, if you have x in power, you ln both sides, right? And now vice versa, if you have log base b, the way you get rid of that is you go b, well, I'm not saying that very well. Power both sides with a base of b. So whatever the base is. So here's the two different game plans we've seen in this section. Logs and powers are opposites. Therefore, if you have x in power, do a log, natural log on both sides. If you have a log, do a power. They're opposites. They undo each other. They're just like an x squared. What do you do with x squared equals, something like 9? You root both sides, don't you? Because they're opposites and then they just cancel each other out. Well, that's kind of what logs and powers, it's exactly what logs and powers are, opposites. So I'm going to come in here and I'm going to go, what's the base? There's the base. The base is 2, right? The base is always the low down number, the number next to g that's lowered down. That's what we call base. It's like, the base of a table is the bottom of a table. So it's the bottom part. So what are you going to do here? You're going to go 2 to the power, 2 to the power. See how that 2 is the base? The base is b, and I'm making the original question, the log. In fact, it'd probably be better if I showed it on another line. So there's the original, and I'll rewrite it here. Log base 2, 5x plus 3 equals 1. And then, you do exactly that. You bring in the 2 as a big old base. Now, why? Well, then these cancel. Because powers and logs are opposites. They cancel each other out. And so you just get this to drop down. You just get 5x plus 3. And 2 to the 1, that's just 2. Right? 2 to the first power is just 2. And on the left side, the base 2 and the log 2 cancel each other out. They're opposites. As long as the base numbers match, a power and a log will cancel each other out because logs and powers are the opposites. That's the theme of this section. If you've got powers, natural log both sides. If you got logs, power both sides by that same base b, whatever the base is. And they'll cancel out. They're like a second power and a root. They're opposites. Okay, now it's easy, right? Now you just subtract 3 from both sides. Boom. 5x is negative 1. Last step, divide by 5. Boom. There it is. Negative 1/5. And they said they want a decimal, so if you divide that in your calculator, negative 0.2. There we go. Let's try another one. Number 11. Natural log 5x plus 2 equals 5. So when you have a log base b, what do? You do the opposite of a log, which is a power. Power both sides base b. Power both sides base b. Now, on this problem here, let me rewrite it. On this problem, what is the base? Remember, the base is is supposed to be right there. It's down by the G for the normal log word, or ln, it's supposed to be some lowered down number. So remember, for ln, what's the base? E. For a normal log, it's 10 if it doesn't show its base, right? It's the invisible base is 10. And if it's ln, it's E. The invisible E is the base. Let me put it there. Invisible E for ln. Invisible 10 for regular log. So if you write the regular log word and don't show the base, it means it's 10. If you write ln, it means it's E. Okay, great. So what? So there's an E there. There's really an E there. Right. So that tells us, remember what you're supposed to do. You're going to power both sides, base B, whatever the base is. Well, now we know the base is E. So E, both sides. And these will cancel each other out because powers and logs are the opposites of each other. They cancel each other out. And so we just have the 5x plus 2. And this other side is e to the 5th. And we'll figure that out in our calculator in a minute. Remember, e is just a special number. Kind of like pi is a special number. You know, pi is 3.14, blah, blah, blah. E is a special number. Pi is 3.14, blah, blah, blah. E is 2.718, blah, blah, blah. It's a special number. You don't have to know it or write it down or anything. Your calculator will take care of it. It knows it. So let's just go on and finish getting, x is saying I want to be alone. So next step, just subtract 2. We got rid of the log, so these are just normal steps now. 5x is e to the 5th minus 2. Last step to get x alone. Divide by 5. There it is. So now you need to hit the buttons on your calculator. Now the E button is right above the natural log. So you probably have to hit second in natural log. Is usually what it is to get that e to the 5th. And make sure you hit equals when you're done with the numerator before you go divide by 5. So probably on most calculators it'll be second natural log, because that'll have e to the x above it, to the 5th minus, and the 5th will, let me try it on mine. So it's second natural log, yeah. And the 5th, you might have to put that in parentheses depending on your calculator. Minus 2, let me get rid of this right here, equals, remember to hit equals, and then divide by 5. So on most calculators, that's what it's going to take. And so that's what it takes on mine. E to the 5th minus 2 equals, divided by 5 equals 29.28263182. Make sure you're able to get that. I don't know how many decimal places they want, but just give them a bunch and they'll be happy. So there we go. So basically, powers and logs are opposites. If you have a power, do the natural log on both sides. If you have a log, power both sides by that same base. For natural log, that base is e. So I e-powered both sides, and it canceled out. Then I got x alone, and I had to type this into my calculator. That's second ln, which is e to the x, 5 minus 2 equals, divided by 5. Make sure you hit equals when you're done with the numerator, and you can get that number. So there we go. Let's go on and try number 12. So number 12, log base 4. X to the 7th is 8. So we're wanting to solve. So how do you solve a log? You power, log with a base b, power both sides base by the b. Power both sides by the b. So I'm going to take this log here. Log base 4, x to the 7th, and I'm going to power both sides by the 4. And these cancel out. Power both sides by the 4, and it cancels out like that. And so we get x to the 7th is 4 to the 8th. Now on your calculator, you're going to need to find, just take 4 to the 8th power. I'll do it too. And we're getting, what's that? 65,536. Good to there. So powers are the opposites of logs. So if you have a log, power both sides by that base. So the base was 4. I powered both sides by 4, canceled out the log. So now we're almost there. How do we finish getting that x alone? Right? We want x. So here's the equal sign. Want x alone, and I want to be alone. Get rid of that 7th power that's on me. Well, to get rid of a 7th power, you do a 1/7 power on both sides, don't you? 1/7 power, and it cancels. So to take this on your calculator, to the 1/7 power, so that'd be 65,536 to the power, that power button, up arrow or x to the y, whatever the power button is on your calculator. 1 divided by 7 equals, or in some calculators it's x to the blank. And you should get it. So to the power, 1 divided by 7, I'm getting 4.876054617. There we go. It says 4 decimal places. And so we got it. You just give them round to 4 decimal places, and they'll be good. Let's try another one. Number 13. Let's see. Natural log of 4x plus 4 is 3. So how do we solve log with a base b? B power both sides. Whatever the base is. What's the base here? I don't see a base right there. So what is it for ln? What is the base for ln always? ln is base e. So that means there's really a hidden invisible little e there. So you don't have to write it in. But that tells you what you're going to do. You're going to e power both sides, and then these cancel, right? Because there's really an e there, and it cancels it out when they match. Powers and logs are opposite. So if you got a power, do a natural log. If you got a log, do a power, and they'll cancel each other out. And so what do we have left now? 4x plus 4 is e to the third. E to the third, our calculator will figure out in a minute. Now our job is to get x alone. So let's do it. Subtract 4 from both sides. Cancels out. We're just getting x alone now. This is e to the third minus 4. Last step is you got to divide by that 4. There we go. Hit the buttons on your calculator. Make sure you hit equals when you're done with the numerator. There. The e button is second natural log on most calculators. And I'm getting 4.0214 rounded to 4 decimal places. They want the answer rounded to 4 they want the exact solution and the decimal to 4 places. So here's the exact. There's the exact solution, and there's the rounded to 4 places, 4 decimal places answer. There we go. There's the 2. They want 2 different answers on this question. There are both of them. Number 14. So number 14, 5 times log base 5 of n minus 9 equals 6. Okay, so how are we going to solve a log? Step 1. Get the log alone. So this time we're going to have some work to do to get the log alone. Step 2. Power both sides by the base. So, all right. So first step, let's get the log. Here's the equal sign. So first off, let's add 9 to both sides. We're got to get this log alone. Just like powers, you got to get them alone first. 5 log base 5 of n equals 9 plus 6, 15. And next step to get x, or the log alone, we are going to divide by 5, right? Because that 5 is multiplied. That 5 in the front is multiplied. That'll get rid of that 5. And so we have log base 5 of n is what? 3. 15 divided by 5 is 3. Okay, so that's all step 1. All of that there that we just did is step 1. We got the log alone. See how the log's alone now? There's not the 9 that was off to the right of it or the 5 that was in front of it. The log's alone. So now step 2, how do you get rid of the log? Power both sides by the base. Power both sides by the base. So let me rewrite it here. What's the base on this one? The base is 5. So power both sides by that base, and this cancels, right? Because powers are the opposites of logs. And so what do we got? N is 5 to the third. Hit 5 to the third in your calculator. 125. Here, I'll just do it another line here. There we go, 125. We got it. There we go. So step 1, whoop, I just erased it. It wasn't good. Get the log alone. Get the log alone and then power both sides by the base. So it's just like what we did for exponentials, right? When x was in power, we would get the base to the power alone and then natural log both sides. Now we get the log alone and power both sides by whatever the base is. All right, these are kind of the same once you see them. So number 15. 9/4 log base 2 of x equals 2. Okay, so solving logs with an equal sign, log equation, step 1. Get the log alone. So is the log alone? Nope, he's got a 9/4. Now, can I subtract that 9/4? No, it's not added. That 9/4 is times. It's right next to the log with no symbol. We know that means times. So to get rid of that 9/4, we're going to have to multiply by the upside down. 4 9. So cancel the 4s and the 9s. That'll put the log alone. What happens on the other side? The 2's over 1. 2 times 4 is 8. 1 times 9 is 9. There we go. So we got the log alone. That's step 1. Get the log alone. Step 2. Power both sides, right? Because powers and logs are opposites. Power both sides by the base. So whatever the base is, power both sides by it. So the base is 2. So power both sides by 2. These cancel because powers and logs are opposites. It's the moral of the story in this section. So what do we get over here? 2 to the 8. Now remember that 8/9 is in the power, right? The base is the 2. It's not 2 times 8/9. It's 2 to the 8/9 power, isn't it? Right? That's what we're always doing. We're powering both sides, not multiplying both sides. We're powering both sides because powers are the opposites of logs. So then just hit the buttons on your calculator, 2 to the 8/9 power, and we'll see what we get. 2 to the power of 8 divided by 9. And you have, for most calculators, you'll have to put parentheses like that. And I'm getting 1.851749425. I don't know how many decimals. It's 4. You can round to 4 decimal places. There we go. So it's always get the log alone, power both sides by the base. That's how we handle logs. Logs are the opposites of powers. Okay, now on number 16, things are going to get a little bigger and messier. We're going to have log x plus log x plus 5 equals 1. And now there's 2 logs. So how do we solve for 2 logs? How are we going to handle it when you have more than 1 log? How do we go about doing that? Well, here's what we have to do. So solving 2 or more logs. Step 1. Combine logs into 1 log by the properties. Now, what do I mean the properties? Adding becomes multiply. Subtraction becomes divide. Remember those properties we learned, those log properties. So step 1, we're going to take these 2 logs and combine them into 1 log. So it's going to become 1 log, not 2. And remember what the properties were? Adding becomes multiply. Here, let me do this better. See how that adding became multiply for 1 log? Remember, it's a harder job for 1 log, 1 person, easier job for 2 logs. It was just adding for 2 logs. It became multiplying, a harder, higher level operation for only 1 person. It's a harder job for 1 person, 1 log, easier job just adding for 2 logs. Remember that property? Adding becomes multiply. If that was subtraction in the middle, then this would have been x log of x over x plus 5, would have been divide. We'll do some of those in a minute. So let's keep going. So now, so that's step 1. So there's step 1. Combine them into 1 log. So if you got 2 logs, make them into 1 log. Step 2, get rid of the log. Get rid of the log by powering both sides by the base. Right? We've talked about that. So let's bring it down a level here. Log of x times x plus 5 equals 1. What's the base? I don't see a base here. So what's the invisible base? For the regular log word, it's 10, isn't it? If that was ln, natural log, the base would be e. So there's an invisible 10 there. So now what does that mean you do? 10, 10, both sides, and these cancel out. Whatever the base is, you power both sides by that base, and it cancels out. Powers and logs are opposites. Okay, where does that leave us? X times x plus 5, because the 10 and the log 10 are canceled, equals 10 to the 1. That's just 10, isn't it? 10 to the 1 power is just 10. Now what do? Well, now we have to solve. Let's multiply, and you get x squared plus 5x is 10. X squared plus 5x is 10. So how do we solve that for x? Well, we got a whole new game plan. We're done with logs. There's no more log here. Let me write out the game plan for us. Solving x squared with an equal sign. We've had this before, but it's a good time to do a little reminder how we solve x squared with an equal sign. Step 1, get a 0. You got to get a 0 on one side. So I'm going to jump this 10 over here, and it's going to become x squared plus 5x minus 10. Remember, when things jump to the other side, they change their sign. Or really, I just subtracted 10 from both sides of the equal sign. Same thing. All right. Step 2. You can factor with the 2 parentheses, you know. Or you can use the quad. Negative b. Whoop, getting scribbly there. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's what we're going to need to do here. This problem's getting a little messy. In fact, I think I'll go to a fresh screen. So x squared plus 5x minus 10. Let's go over here. X squared 5x minus 10 is 0. And I'm going to write out the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's identify. A is 1, b is 5, c is negative 10. All right, so x is negative b, negative 5 plus or minus the square root of b squared. 5 squared minus 4 times a times c all over 2 times a. And so where does that leave us? Negative 5 plus or minus square root of, what is this, 25 plus, right, it's negative times positive times negative. 2 negatives, positive 40 all over 2. And that's square root of 65 all over 2. Like that. So that's two different answers. So that's going to be negative 5 plus the square root of 65 all over 2, or negative 5 minus the square root of 65 all over 2. So let's use our calculator. Figure those out. Remember to hit equals when you're done with the numerator before you divide by 2, so that you get the whole answer to the numerator and you're not just dividing by the last thing. And I'm getting, for the first one, I'm getting 1.5311288874. For the other one, I'm getting negative 6.5311288874. Okay, so what's the deal with this situation? So are there two answers to this problem? Whoops, getting scribbly over here. Are they are they both valid and good answers? Well, we go back to the original problem. See how we have log x here and x plus 5 there? We're saying x is this, or x is that. We get two answers for x. It's this, it's the positive 1.53 whatever, or the negative. Well, here's a special rule you need to know about log answers. The inside of a log can never be 0 or negative. Can never be 0 or negative. You can try it in your calculator real quick if you want. Try log of 0 or log of negative 1. It'll be air. Both those will be air. So if we take, so positives are fine, but the inside of a log can never be 0 or negative. What I'm saying is this is a bad answer. It's a false answer. You can actually get false answers when you're solving a log equation. It's pretty tricky. See, if I took that answer and I tried to plug it back in right there, the negative 6 point, whatever it is, 6.5311, whatever, and tried to plug it in there and there for x, it would make the inside of that log negative, which is just an error. It's not a real answer. So that one's out. The only answer is the 1.5311 answer. That's the real answer that actually works. You could plug it in. It would work. You don't need to plug it in. You just got to make sure that you're never having the inside of a log be negative or 0. So no answer to a problem. Any problem that begins with logs, you cannot, whatever x is when plugged in, cannot make the inside of the log negative or 0. If so, you throw it away. It's not a real answer. The only real answer is the 1.5311. There we go. It's kind of tricky, number 16. All right, let's try number 17. So we get ln of x plus ln of x minus 5 equals, okay, ln of 7x like that. Okay, so let's see. Okay, so you know the game plan. When you got two or more logs with an equal sign, step one is combine the logs using the properties, meaning adding becomes multiply and subtraction becomes divide. So this adding is going to become multiply, x times x minus 5. So we combine those two logs. See how it's one? It was two logs on the left side. Now it's one log multiplied. So the easier operation of adding becomes the harder operation of multiply. Multiply is a higher level operation. You learned that when you were older. You learned adding is the first thing you learned in math. So it's an easier job for two logs, harder job for one log. That's the properties we learned in an earlier section. And now, how can we get rid of these logs from both? So what's step two? You get rid of the ln, or whatever the log is, by powering both sides by the base, right? Because powers and logs are opposites. So what's the base? I don't see a base. It's an invisible e, right? ln has a base of e. So power both sides by a big old e, which cancels out the base on both sides. Both of them. And we just get x times x minus 5 equals 7x. Just like that. And now if we distribute this, we get x squared minus 5x is 7x. Now what are we supposed to do to solve this thing? Well, we go into a whole new game plan now. Solving x squared with an equal sign. Step one is to get a 0 on one side. So let's subtract 7x from both sides. That'll produce a 0 over here, and this will be x squared, what, minus 12x, won't it? Right, we just combine those, get a 0. Step two, factor or use the quad, but in this case we can just factor, right? You can just take out an x. Leaves x minus 12, right? Because that x could multiply and go back to x squared minus 12x. You see that? I just factored. And then each part equals 0. Meaning the x alone is 0. Or the x minus 12, I'll say, or the x minus 12 is 0. Now why? Why can we go from 1 equals 0 to 2? Why can we set each part equal to 0? Remember the logic of that? If you have two things multiplying to equal 0, that means either one could be 0, right? If I said, hey, I'm thinking of two numbers, and in my head, and the first number times the second number is 0. You know what that means. The first number could be 0, because 0 times anything is 0, or the second number could be 0, because anything times 0 would be 0. Well, that's what's happening here. We have x multiplied, right? Parentheses means multiply, by x minus 12. So this first one could be 0, or this second one could be 0. Either way, they'll multiply to equal 0. So the first one could be 0, or the second one could be 0. We got to finish solving the second one. Add the 12 to both sides. So x is 0 or x is 12. But remember what we learned? Bye-bye 0. That's a false answer. Why? Because if you go back to the beginning of the problem, if you made x 0, it'll make this 0, it'll make that negative, and here as well, it'll make that 0. Remember the inside, I'm running around a room here. The inside of a log is never 0 or negative. The inside of a log can never be 0 or negative. So throw away that answer 0. The only answer to this problem then is the 12. There we go. Let's go to number 18. So 18 log x plus 2 minus log x plus 1 equals 1. So you remember solving logs with an equals, or two or more logs, I should say. Two or more logs. Step 1, combine the logs by the properties. Remember the three log properties. Adding becomes multiply, subtraction becomes divide. The third log property was about powers coming down to the front. We don't need that here. We did that a lot earlier in this section. So I'm going to combine them. So subtraction now. Subtraction with two logs becomes divide, doesn't it? Subtraction goes to divide. You see, if that had been a plus in the middle, I would have multiplied the x plus 2 and the x minus 1, but it was minus. Whoops, that's a big minus sign. It was minus, and minus leads to divide. So those are the properties. So we did minus leads to divide. Now, let's rewrite it. We got log x plus 2 over x plus 1 equals 1. So what is step 2? So first step is you combine the logs using the properties. Make them into one log. Step 2 is you cancel the log, get rid of the log by powering both sides by the base. Now what's the base? I don't see any low down number next to the G. Well, there must be a little 10 there, right? If it's ln, the base is e. If it's the normal log word, the base is 10 when it's invisible, when it's not showing. So I'm going to do 10 powered to both sides. And these cancel out, right? Powers are the opposites of logs. And so where does that leave us? X plus 2 over x plus 1 is 10 to the 1. 10 to the 1 is just 10. Now, how in the world are we going to solve that equation? How are we going to solve that? Remember when you have a fraction on one side and a whole number on the other? You just put this over 1, you go diagonal, diagonal. So it'll be 1 times x plus 2 is 10 times x plus 1, right? I just went diagonal, diagonal. 1 times x plus 2, 10 times x plus 1. All right, let's keep going. And so we distribute. So x plus 2, distribute. 10x plus 10, I'm multiplying there. How do you solve for x when it's on opposite sides? And notice we don't have x squared here. So I don't have to do any of the fancy, like the last couple of problems we had x squared and we had to get a 0. Whenever you have x squared, it's all about getting a 0. But we don't have x squared here. We just have regular x. So how do we get it alone? When you have it on both sides, get rid of the lower one. Boom, it's gone there. And this is 9x plus 10 is 2. And now it's getting easier. Subtract 10 from both sides. Bring it over here. What's that going to be? Negative 8 is 9x. So these cancel. And then last step, divide by 9. There it is. Minus 8/9. Now you might say, wait a minute, Stern, you said that you can't have negative answer for a log. No, careful. Careful, I did not say that. What I said is the inside of a log cannot be 0, right? I don't know where to write that here. Let me write it right here in the middle. So if you look back, here, let me show you. Right here, see these words? Inside of a log is never 0 or negative. Let me write that again for you. I mean what I say what I mean. I don't mean other things. Let me explain. The inside of a log is never 0 or negative. Okay, so minus 8/9, let's take it back here and let's plug it in. If you put in right here for x, if I have some room to if you put in minus 8/9 right there, and minus 8/9 right there, for x, What's minus 8/9 plus 2? Well, I'll just take my calculator real quick and I'll go minus 8 divided by 9 plus 2. I'm getting, this will be log of positive 1.111 forever. Notice the inside of the log is not negative. It comes out positive. Even though I plugged in a negative 8/9 for x, the inside of the log still came out positive because 2 is bigger than 8/9. So 2 minus 8/9 is still positive. Same thing over here. Minus 8/9 plus 1, it's going to come out positive. It's again, it's 0.1s forever, 0.111 forever. So it's okay. In fact, you can tell it's, well, yeah, I'll leave it at that. It's okay. It doesn't make, the inside of the log is not 0 or negative. So that's an acceptable answer. So we were never saying that you can't get a negative answer to a log problem. You can get a negative answer. We did here. This is the correct negative answer, negative 8/9. Or you could make it a decimal. Either way, it doesn't matter. That's the correct answer. What you can't do, when you plug it in, the inside of the logs can't be 0 or negative. And this one, the inside of the logs, stay positive. So this one's a keeper. He's okay. He's an acceptable answer. Number 19. Log base 3 of x squared minus log base 3 of x plus 4 equals 7. So you know the drill. Solving with 2 or more logs. Step 1, combine the logs by the properties. Adding becomes multiply, subtraction becomes divide. So subtraction. So this will become log base 3 of x squared over x plus 4, right? That subtraction becomes divide. Right? Subtraction becomes divide. Step 2, cancel the log by powering both sides by the base. So what's the base here? Well, the base is right there. It's 3. The base is clearly 3, so I'm going to power both sides by that base, and that cancels out. Logs and powers are opposites as long as the bases match. The power and the base match, and they'll cancel. So what does that leave us? X squared over x plus 4. And then on the other side, some whopping number. Take your calculator. 3 to the 7th power. It's going to be big. 2187. Okay. Now, how do we solve that equation? What are we going to do? Well, when you have a fraction, remember what you always do when you have a fraction? Put this thing over 1 and go diagonal, cross multiply. So we get 1 times x squared is 2187 times x plus 4. 1 times x squared is just x squared. Distribute this. 2187x plus whatever 4 times 2187 is. My calculator just told me 8748. What in the world? We got rid of the logs, but how are we going to solve this now? Remember how we solve x squared? We have to get a 0. So let's go to a fresh screen. We're going to need a fresh screen on this one. X squared. So x squared equals 2187x. So x squared is 2187x plus 8748. So now solving x squared with an equal sign. Step 1, get a 0. So let's jump this guy and this guy to the other side. So we get x squared minus 2187x minus 8748 equals 0. So step 1 is to get a 0 on one side. That's what we always do. So you got to get really comfortable with that. It's going to come up a lot. Whenever you've got x squared with an equal sign, step 1, get a 0 on one side. So we've got a 0. Step 2, you can try to factor, with the parentheses, or we don't want to factor. Use the quad. This one's going to be much better with the quad. So I'm going to use the quad. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's quad it. So the a here is 1. The b is this negative 2187, and the c is this negative 8748. So negative b, negative 2187, that's going to become positive, right? Plus or minus the square root of b squared, negative 2187 squared, minus 4 times a times c, negative 8748, all over 2 times a. Whew, what a mess. So let's keep going here. So 2 negatives here make positive, right? Negative b, and b was itself also negative, so that's positive now. Positive 2187 plus or minus the square root. 2187 squared, these are big numbers. Wow, really big. I'm getting 4,782,969 plus. So negative times positive times negative. So 2 negatives, see how I knew it was going to be plus? Because it's 2 negatives. 4 times 1 times 8748. I'm getting 34,992 all over 2. Okay, so that's 2187 plus or minus. And so add those two numbers together on the inside. I'm getting the square root of 481,7961. 4,817,961 all over 2. All right, this is big and it's ugly. So we're going to have to get 2 separate answers. 2 separate answers for this one. So the first one is going to be the 2187 plus the square root of 4,817,961 over 2. So make sure when you put that in your calculator, make sure you hit equals when you're done with the numerator before you divide. So I'm going to do that. And I'm getting the answer for that one to be 2190.992711. Now, the other answer is going to be 2187 minus the square root of 4,817,961 all over 2. And if you hit the buttons on your calculator on that one, I'm getting negative 3.9927106, blah, 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 blah. That's a valid answer, actually. You might think, well, no, you can't have a negative, but actually, if you plug that in here, you see that's negative 3.9, so add 4, the inside will be positive. If you plug it in there, it's squared, so anything squared is positive. That's an acceptable answer, but if you notice in the question, let me go back here to the question on number 19. They said, find the largest value of x that works. They only want the larger one. They don't want the smaller one. So because they said that, and only because they said that, we will only give them this answer. This is the only one they want. The other one is actually valid. Even though it's negative, it doesn't make the inside of a log negative. It would technically be another valid answer, but they only want the bigger one. So we'll just give them the bigger one. There we go. Number 20, the last one on this section. The log of x plus 13 equals the log of x plus the log of 13. Okay. How's this going to work? So you know the deal. Solving with two or more logs. Step 1. Combine the logs by the properties, meaning adding becomes multiply, subtraction becomes divide. So we have adding, so that is going to become multiply. Whoops. X times 13. Like that. Multiply, right? This adding becomes times, becomes multiply. Let me make that a little more clear here. X times 13 is multiplied. Adding becomes multiply, right? Adding for two logs. Easy job for two logs. Adding, simple operation, becomes a harder multiplying for only one log. Harder job for one person. Easier for two. Okay? Now, whoops, that's 13. Okay, step number 2. Cancel the logs by powering both sides by the base, right? What's the base? I don't see a base on this one. There's invisible 10, right? When you have if you have the ln, it would be invisible base e. If you have the regular log words, invisible base 10. And so we 10 power both sides, and the 10s cancel out the logs. When the powering and logs are opposites of each other, as long as the bases match. And so what do we got now? X plus 13 is x times 13. In other words, that's 13x. And this is x plus 13, and we're trying to solve for x now. How do you solve for x when you have x on opposite sides? You get rid of the lower one. Boom. So 13 is 12x, right? 13x minus 1x is 12x. Last step to get x alone, divide by 12. There it is. 13/12. Hit the buttons on your calculator. It is 1.08 with 3's the rest of the way. There's the answer for x. We got it.